So, welcome to the land of Aspire to Do's. This is going to kind of introduce you to some seventh grade concepts that you'll explore perhaps more deeply in your future. For now, it's kind of a fun place to travel and see kind of where these rates and ratios, this information you've been practicing and exploring with rates and ratios, one of the places it can guide you. So, a proportion. Let's get a pen. A proportion, right, is simply an equation. So an equation has an equal sign in it, implying that everything on one side of this equation, in this case 2/3, is exactly the same value as everything on the other side of the equation, perhaps having a different look. So an equation with two equal ratios, right? So 2/3 is equal or proportional to 4/6. It just looks different. 5/15 is equal or proportional to 1/3. Different look, same value. Where it starts to get fun is that you're going to start seeing that there becomes some mysteries. So, a proportion can also have variables being those unknowns, right? So, you might find that you have 5/16 as a given. And then your job is to try to figure out, well, what's X, right? What's this mystery? What's the proportion, a mystery amount of eighths that's equivalent? So as you get exploring that, let's go over here. There's a couple different kind of approaches you can take to dig into this and explore it and solve those mysteries. So, one thing you can think about is using what you know essentially about DIVA, right? About finding equivalent fractions, equivalent ratios, similar here with proportions. So, here we're given 2/6, and we want to know how many, right? If we have 10 how many's, 10 what's equivalent? So, um, as you can see, we've essentially used a diva. We've multiplied. We said, well, what can I multiply 2 by to get to 10? I can multiply it by 5. So I can do that same thing on the bottom, and I can find my proportion, right? So this becomes 6 times 5, which is 30. All right. You can go backwards. You can make it smaller. You could, right? You could like divide and turn it into 1/3. But in this case, we specifically wanted to solve for X. Now, sometimes, right, it won't necessarily be as even and as familiar of facts. And so you might have a harder time just sort of finding a diva to use, right, to hit what you want to hit your target, to solve your mystery. So another strategy, let's choose a different color, is you can do what we're calling setting the products of the diagonals equal to each other. So if we're given 6/15, okay, and we're like, ooh, okay, I'm trying to solve this mystery. A mystery amount of 20ths is a proportion, is proportional. What do I do? Well, one way you can approach this is you can zoop, look across, so on the diagonal, and they're saying you can set the product of the diagonals. Product meaning answer to a multiplication problem. So you can see 6/20 and you can see 15x, right? 15 times x, the product of that will be equivalent to the product of 6 times 20. Okay. So then you can solve. So you say, okay, well, in order to solve, just like in hands on equations, what I know is that whatever I do to one side is legal to do so long as I can do that same thing to the other side. We'll also be thinking about inverse operations here. So if we think about, okay, 15 and X, they're sort of like getting real annoyed with each other. And so X sort of wants its own space, right? They need a little social distance, if you will. So what we're going to do is we're going to see if we can simplify anything first, if we can combine any like terms. 15 and X, they're different types of terms. So we're not going to be able to combine anything there, but we know that 6 and 20, they're both whole numbers, so we can multiply them. We get 120. And then what we can do is we can say, okay, X, no, seriously, X needs some social distance. It needs a little space from 15. So we're going to give it that by undoing the multiplication. So we're going to divide by 15. That's a 15. These end up canceling out. 15 divided by 15 is 1. So we're just left with 1x equals 120.